Hello students, welcome to my channel E-Class. Today is the part 4 of set theory of Ncert class 11 math book. Okay. So if this video is helpful to you, then please like, share and subscribe my channel. And if you missed the previous videos, then please watch them first and then the part 4. Okay. So let's start our today's topic, that is Venn diagram. So Venn diagram is a very important topic in set theory. Okay, so what is Venn diagram? Most of the relationships between sets can be represented by means of diagrams which are known as Venn diagram. So there are many relationships between sets and we can represent most of them by diagrams or by pictures are known as Venn diagram. So what is the relationships? So take a relationships between set, that is we take two set A and B and take a relationship of subset, that is A is a subset of B. If you don't know what is subset, please watch part 3 of set theory. Okay, so take a relationship A subset B. Okay, that's mean all the elements of A are elements of B also. All the elements of A are elements of B also. So now take A equals to second bracket 1 2 3 4 and B equals to 1 2 3 4 5 6 7. So 1 2 3 4 are elements of A and 1 2 3 4 5 6 7 are elements of B. So we take two set. Okay, we represent set in Venn diagram by circle, and we represent the universal set by rectangle. Okay, by rectangle. So the rectangle represent universal set. Okay, now since A contains 1 2 3 4 these elements, and this 1 2 3 4 is also an elements of set B. So the small set, that is a small circle, represent A and the small circle represent A, so the big circle represent B. So A contains 4 elements, that is 1 2 3 and 4, and other elements, that is extra elements of B, that is 5 6 and 7 are in this region. Okay, so this is how we can represent the relationship A subset B using these pictures, and this picture is called Venn diagram, and this represent A subset B, the relationship A subset B. Okay, now operations on sets. What is operations? There are many operations like plus, minus, divide and multiplications. So these are operations of real numbers. So in case of set there are also operations. There are mainly 3 types of operations in case of set. First of all is union, second is intersection, and the third one is difference. So first one is union, second one is intersection, and the third one is different. So let us take two set A and B. Okay, to set A and B, and the union of A and B is symbolized by U. Okay, like this U. Now intersection, take to set A and B, and their intersection is symbolized by this symbol, and difference means, you know, subtract, that is A minus B. So for union we use this symbol, for intersection we use this symbol, and for difference we use minus. So there are three types of operations on sets: union, first one union, second one intersection, and third one is difference. So what is union? So what is union? The union of two sets A and B. So union of two set A and B is the set C, which consists all those elements which are either in A or in B. So basically, union of any two set is also a set, that is C, and it contains all the elements of A and B, Okay. So by symbol we can write this as A union B. So what is A union B? This is the set C. So set C equals to A union B, and we represent in set builder form like this, that is A union B. The elements of A union B are X, such that X belongs to A or X belongs to B. That is, all the elements belongs to A or B are elements of A union B. So let us take example. So there are two sets A and B. So A contains 2, 4, 6, 8, and B contains 6, 8, 10, 12. We have to find A union B. Now look, there are some common element between A and B. Like 6 and 8. That is 6 and 8. These two elements are common between A and B. Now look at the picture. If we consider the blue one as set A and the chocolate colored one as B. So this one is A, that is the set. Okay, this whole set is called A, and the whole brown set is called B. Okay. Now the yellow colored portion is the common area of A and B. So A and B have 6 and 8, these two elements in common. So yellow area consists of two elements, that is 6 and 8. Now other two elements of A, that is 2 and 4 are in this region, in this blue region, okay, of A, and the other elements of B, that is 10 and 12, are in the brown region of B. So here is 10 and here is 12. So A union B is the elements of A union B such that X belongs to A or X belongs to B. So the union A union B equals to all the elements of A and B. Okay, so the elements are 2, 4 in this blue region. Now the common element, that is 6 and 8 in the yellow region, and 10 and 12 in the brown region. So for these two set A and B, A union B equals to 2, 4, 6, 8, 10, 12. So whenever you calculate A union B, first of all you have to so you have to you have to calculate the common number. So first of all the common numbers, you find the common numbers between the two sets 6 and 8. So first of all you have to write this common number. This is the basic method. Okay, so first of all you write the common number, then the other numbers. For A the other numbers is 2 and 4, and for B it's 10 and 12. Okay, so this is very common method. Okay, so first of all you have to find the common numbers between two sets or three sets maybe, and then the others number, you have to write the others number. Okay, and you get A union B. So this picture is a Venn diagram of A union B. Okay, now there are some properties of A union B. There are some properties of A union B. The first property is A union B equals to B union A. A union B equals to B union A. So for this we take an example. Okay, for this we take an example. Let A equals to 1 2 3, B equals to 2 3 5 6, and C equals to 3 6 9. So we just take three sets A, B and C. Now for the first case, that is A union B equals to B union A. So A union B equals to, so first of all you have to find the common elements between A and B. So the common elements is 2 and 3 between A and B. So you have to write 2 and 3 first. Then the other elements, that is for A is 1 and for B is 5 comma 6. Okay. Now if you calculate B union A, so you have to first write the common elements of B and A, that is 2 and 3. Then the other elements of B, that is 5 and 6, and the last one is the common element, the other element of A, that is 1. As you see, A union B and B union A, for A union B and B union A there are the similar elements 2 3 1 6 and 5. The elements are similar, so we can write that A union B equals to B union A. These two are equal sets, so A union B equals to B union A. This is the first property of union, and this is called commutative law. This is called commutative law. Now the second one, that is you have to calculate A union B union C. A union B union C. So first of all we calculate A union B union C. A union B union C. So for this we have to first calculate A union B. So what is A union B? The union B is 1 comma 2 comma 3 comma 5 comma 6. This is A union B. Now union C, that is 3 6 and 9. Now the common elements between these two sets are 3 and 6. So 3 and 6 are, we write 3 and 6 first, then the other element of the first set, that is 1 to 5, and the other element of the last set, that is 9. So this is A union B first bracket union C. Now we have to calculate A union B union C. So what is A? A is 1, 2, 3 union. Now B union C. So the common element between B and C are 3 and 6. So first of all we write 3 and 6, 3 and 6. Okay. Then the other element 2, 5, 9. And after calculation we get these two union, we get 3 and 2 each common. So 2, 3, then the other element is 1, and for these two 6, 5, 9. For this 6, 5, 9. So look at the elements of these sets and this sets. You see that both of them contains the same element, that is 1, 1, 2, 2, 3, 3, 5, 5, 6, 6 and 9, and here is 9. So both of them contains the same element. So we can write A union B first bracket union C equals to A union first bracket B union C. So we can write that these two sets is equal, and this property is called, associative law. Okay. Now the third property. Now we discuss the third property. Let me erase all this. So the third property is A union phi equals to A. A union phi equals to A. So A union phi. What is phi? Here phi is an empty set which contains no element. Okay. So A union phi. So first of all we write A union phi. So phi contains no element. And what is union? Union is a set which contains elements of A or elements of B. Okay. So there is no elements in phi. So A union phi contains the elements of A, that is 1, 2, 3. Because there is no element of phi, so A union phi, the set A union phi contains only the elements of A. So A union phi equals to 1, 2, 3, and 1, 2, 3 is equals to A. So we get A union phi equals to A. Okay. And this property is called law of identity element, and phi is the identity of union. So phi is the identity of union. What is identity? Okay, identity of union. So if we add any number, with 0, we get the number. If we add anything, we get the same number. So 0 is the identity element of plus. Like this, if we multiply any number by 1, we get the same number. Okay. So 1 is the identity element for this operation multiplication. So here if we calculate union of a set A or B with 5, we get the set. So this is also an identity element. So 5 is an identity element of the operation union. Okay. Now fourth is called A union A equals to A. A union A equals to A. A union A equals to, now first of all we find A union A. So just write A union A. So to calculate this union, we first find the common element. Here the common element is 1 2 3, and then we have to write the others element, but there is no other element. Okay, and we get A union A as 1 2 3, and 1 2 3, the set 1 2 3 is already denoted by A. So A union A equals to A, and this is called idempotent law, and this is called idempotent law. Now the last one is universal set. Union any set is the universal set. Okay, now we take an universal set. U for the set A as 1 2 3 4 5 6. So this is the universal set for the set A. So union of universal set and A equals to, so first of all we have to calculate we have to find the common number or common element, that is 1 2 3, then the other elements 4 5 6. So we get the set 1 2 3 4 5 6, which is equals to U. So if we calculate union of universal set and any other set, we get U, that is the universal set. This is called law of universal set. Okay, so these are some properties of union. Now we're talking about intersection. So what is intersection? The intersection of two sets A and B is the set, you can say any set like C, is the set C of all those elements which belongs to both A and B. So the meaning of this line is that intersection of A and B, is a set which contains those elements which are common in A and B, So now this is the symbol of intersection. So A intersection B is a set which equals to, the elements of A intersection B are X, such that X belongs to A and X belongs to B. That is, the elements of the set A intersection B are the common elements of A and B. So for this example, if we calculate A intersection B, we get the set which contain the common element. Now the common element between A and B are 6 and 8. So A intersection B contains the common elements of A and B, that is 6 and 8. Now look at this picture. The blue set is A and the brown set is B, and the yellow and this yellow region is the common area, or is the common area. So this common area represent A intersection B, that is any elements between this between in this common area are elements of A intersection B. So this common area shows A intersection B. Common area represents A intersection B. Okay. So there are some properties of intersection also. Okay. Like union. Okay. So the first properties, for this we take examples, that is 1, 2, 3. B equals to 2, 3, 5, and C equals to we take 1, 2, 5, 6. C equals to we take 1, 2, 5, 6. Now the first property we have to calculate A intersection B. So what is A intersection B? The common elements of A and B. So the common elements of A and B are 2 and 3. So A intersection B equals to 2 and 3. Now B intersection A. What is B intersection A? B intersection A is the set which contains the elements which are common in B and A. So this is also contains 2 and 3. And we can see that A intersection B and B intersection A contains the same elements, that is 2 and 3. So we can say that A intersection B equals to B intersection intersection A, and this property called commutative law. This property is called commutative law. Now for the second property, we have to calculate A intersection B within the first bracket intersection C. So first of all we calculate A intersection B. So A intersection B is 2, 3, intersection right C 1, 2, 5, 6. Now intersection of these two sets we have to write the common elements. So there are only one common elements between these two sets, that is 2. So A intersection B within bracket intersection C equals to, we get 2. Now the right hand side, A intersection within first bracket B intersection C. So first of all we have to write A, that is 1, 2, 3, intersection. Now B intersection C, we have to calculate B intersection C. So B intersection C will be 2, 5, because these are the two elements which are common between B and C. Now for this intersection there are only one common element, that is 2. Now we can see that A intersection B within bracket intersection C equals to A intersection within bracket B intersection C, because both of them contain the same element, that is 2, and this law is called associative law. Now for the third property, that is phi intersection A. Phi intersection A equals to phi. Phi intersection A equals to phi. Okay. Okay. For the third property, phi intersection A. Now we know that phi is the empty set and phi does not contain any element, and phi does not contain any element, but A contains 1 to 3. So we just write phi intersection 1 2 3, but there is no common element between phi and this set A, because phi contain no element, so there is no common element. So phi intersection A contains no element, contains no elements. So this is equals to usually phi. So we get phi intersection A equals to phi. Now the second property under 3, that is union intersection A equals to A. Union intersection A equals to A. Now we can, first of all, we write a set U, that is the union set of A, as 1 2 3 4 6. So U intersection A equals to, we get, now 1 2 3 is common in both A and U, so 1 2 3. So union intersection A equals to, we get 1 2 3, and 1 2 3, the set 1 2 3 represent the set A. So we get union intersection A equals to A. Okay, so this complete the third property, and these are called law of phi and U. Okay, now the fourth property is A intersection A equals to A. A intersection A equals to A. So A intersection A. What is A? 1 2 3. And what is A? 1 2 3. Now the common element between these two sets is 1 2 3, and 1 2 3 represent the set A. So A intersection A equals to A, and this is called idempotent law. This is called idempotent law. Now the fifth property. That is, we have to calculate for the fifth property, A intersection within bracket first bracket B union C. So we just write A, that is 1 2 3 intersection. Now B union C. What is B union C? First of all, to calculate B union C, we just write the common element, that is 2 and 5 between B and C, and the rest element, that is 3 for the B and 1 6 for C. So this is B union C. Now for intersection between first and this second set, we just write the common elements. So there are 1 2 3, and here is 1 2 3 are common, so equals to 1 2 3. So we get A intersection B union C equals to 1 2 3. Now we calculate the right hand side, that is A intersection B within bracket union A intersection C within bracket. So what is A intersection B? So A intersection B, the common element between A and B is 2 and 3. So A intersection B equals to 2 and 3. Now union. Now A intersection C, the common element between A intersection C is 1 and 2, is 1 and 2. Now we have to calculate the union of these two sets. So just write the common element first, then the rest elements, that is 3 and 1. And we see that for the left hand and the right hand, the left hand set and the right hand set both contains the same elements, that is 1 2 and 3. So we can say that A intersection within bracket B union C equals to A intersection B within bracket union A intersection C, and this is called distributive law. This is called distributive law, that is intersection distribute over union. Intersection distributes over union. Okay. Now difference, that is we have to calculate subtraction between two sets. So what is difference? Difference of A and B, difference of two set A and B is in this order. So for difference you have to notice the order, you have to remember the order. Okay, so here order is matter. Okay, for union and intersection, for union and intersection the order does not matter. For union and intersection order does not matter, but for difference order is matter. So the difference of the sets A and B is in this order. Okay, so first of all we have to write A and then B in this order. Is the set of elements, is the set of elements which belongs to A but not in B, and we symbolize as A minus B. So what is, so the meaning of these lines is A minus B, A minus B is a set, say C, okay, which contains the elements of A but not of B. So A minus B is a set which contains the element of A but not contains the element of B. Similarly, if we write B minus A, so B minus A, the elements of B minus A, of the set B minus A, only contains the element of B and not the elements of A. So the difference of two set contains the elements of the first one, not of the second one. Okay, so we take an example. A equals to 1 2 3 4 5 6 and B equals to 2 4 6 8. Okay, so we have to find A minus B and B minus A. So first of all look at the picture. So what are the common elements between A and B? What are the common elements between A and B? The common elements between A and B are 2, 4 and 6. These three are common elements of A and B. So these three elements are in the yellow region, of this, that is the common area of this two set. So here is 2, 4 and 6. So 2, 4 and 6 are in the common region, that is in the yellow region of A and B. We take blue one is A and the brown one is B, and the pink, that is the universal set, that is U. Now the other element of A are 1, 3 and 5. 1, 3 and 5 are in the blue region of A, 1, 3 and 5. Now the other element of B is 8. So 8 is in the brown region of B, So first of all you have to notice that 2, 4, 6 is also elements of A and also elements of B. Now we calculate A minus B. Now we calculate A minus B because A is written first, then B. So A minus B contains the elements of only A. Which are the elements of only A but not of B? Now the elements of A are 1, 2, 3, 4, 5, 6. But 2, 4 and 6 are also element of B. So A minus B does not contain 2, 4, 6 because they are elements of B. Okay. So A minus B contains those elements of A which are not common with B. That is, A minus B contains the elements only in only in A. A minus B contains those elements who are only in A, that is in the blue region. So A minus B equals to 1, 3, 5. Now B minus A. So we write B at the first. So B minus A are set which contains the elements of only B. That is, which elements are belongs to the brown region of B, that is 8. So B minus A equals to 8. Okay. As 2, 4, 6 are also elements of A, so 2, 4, 6 does not belongs to B minus A because B minus A contains the elements of B only. Okay. So this is difference. Now we have to know what is mutually disjoint set. Mutually disjoint set means two sets A and B is called mutually disjoint if there is no common element. If there is no common elements. Okay, between A and B, that is the intersection, that is therefore A intersection B equals to phi. If the intersection of any two set is phi, then these two sets called mutually disjoint sets. Okay, because there is no common element. If there is no common element between two sets, they are called mutually disjoint set. Or if the intersection of the two set is phi, it also calls disjoint sets, mutually disjoint sets. Okay. Now the yellow. Now look at the picture. The yellow region is the common area. That is, yellow region represent intersection. If this is, consider this as A and this as B. So this yellow region represent A intersection B. Now the blue region. Now this blue region contains the elements of A minus B because A minus B contains the elements only in A, not in B. Okay, and B and the brown region of B contains the element of B minus A. As you notice, A minus B. So this is the region of A minus B. Okay, this is the region or area of A minus B. This is the region of A intersection B, and this is the region of B minus A. Okay, so A minus B and A intersection B, there is no common element between A minus B and A intersection B. Also, there is no common element between A intersection B and B minus A. And again, there is no common element between A minus B and B minus A. So we can say that A minus B, A intersection B and B minus A are mutually disjoint because there is no common element between these three sets. Okay. So this is all about mutually disjoint sets. Now we solve exercise 1.4. Now we solve exercise 1.4. The first question is you have to find the union. You have to find the union of these sets. Okay. So the first two sets are X and Y. So you have to calculate the union of X and Y. So X union Y equals to, so first of all you have to write the common elements of X and Y, that is 3 and 1. So write 1 and 3 first, then the remaining elements of X and Y, that is 5, and for Y is 2. So comma 5 comma 2 you can write in order, that is 1 comma 2 comma 3 comma 5. So this is the X union Y. Okay. Now number 2, A and B. Okay. So you have to calculate A union B. So first of all you have to write the common elements, that is A, and there are no other common elements. So just write A, then the other elements of A, that is E, I, O, U, and now the other element of B, that is small b and C. So this set is represent A union B. Okay. Now the third question is A equals to X such that X is a natural number and multiple of 3. So X is a natural number and multiple of 3. So we can represent this set as A equals to 3, 6, 9, 12, comma, write some dots because there goes to infinity. Now number B, what is number B? The set of number B, X is a natural number less than 6. Less than 6. X is a natural number less than 6. So this will be 1, 2, 3, 4 and 5. Okay. X is a natural number less than. Okay. So 6 is not included. If 6 is included, then it will be lesser equal to 6. Okay. But here is less than 6. So 6 is not included. So A union B equals to, first of all you have to write the common. So the common is 3. Okay. So the common is 3. We write 3 here. Okay. There are no other common numbers. So we have to write the, first of all we have to write the common of B. Okay. 1, 2, 4 and 5, then 3, and then the other element of A, that is 6, 9, 12 and some dots. Okay. We write B first because 3, 6, 9, 12, the set A goes to infinity. So we have to write in the last. Okay. We have to write set A in the last. So this is A union B of question number 3. Now 4, question number 4. For question number 4, the set A 1 less than X less or equal to 6 and X is a natural number. So the elements of A will be 2, 3, 4, 5 and 6. And for B, X is a natural number and X is between 6 and 10. So 6 and 10 are not included. So 7, 8 and 9. So A union B, so A union B equals to, the common elements are, is there any common elements? No. So just write the elements of A and B. If there is no common element between A and B, in case of union, just write the elements of A and B together. So 2 3 4 5 6 7 8 and 9. Okay, 7 8 and 9. Now the last question, A equals to 1 2 3, B equals to 5. The property of union, in the property of union, we notice that union of any set with phi is always A. So for this case, A union phi will be 1 2 3, as A is 1 2 3. So this is the answer. So this is question number 1, which we done. Now question number 2, let A equals to A and B and B equals to A B C. Is A subset B? What is A union B? Is A subset B? Yes, A subset B. Yes, A subset B, because the elements of A is also elements of B. Elements of A is also an elements of B. So A subset B. Okay. Now A union B. For A union B, first of all we have to write the common elements. So the common elements between A and B are A comma B, and the remaining elements are C. So A union B equals to A B C, which is the set B. So A union B, in this case A union B equals to B. Question number 3. If A and B are two sets such that A subset B, then what is A union B? As you see in question number 2, that is where A equals to AB and B equals to ABC, as you see in question number 2, and we find that there A and B are subsets, that A subset B, and we get A union B equals to B, as you see in the previous question. Okay, in this question here A subset B, so we get A union B equals to B. So for this question 3 also, if A subset B, then we get A union B equals to B. Now question number 4, there are some sets A, B, C and D, find A union B. So A union B equals to, there are common numbers between A and B are 3 and 4. 3 and 4, so the remaining one is 1 2 5 and 6. You can write in the order, okay. So just write 1 2 3 4 5 6. So this is your answer. Now A union C, there is there any common number? No. So just write, is there any common number? 5 6 7, 1 2 3 4 5 6 7 8. So there is no common number, so just write all the elements of A and C. So 1 2 3 4 5 6 7 8. Now B union C, there are common numbers, that is 5 and 6 between B and C, and others the number are 3 4 and 7 8. And now we just write in order, that is 3 4 5 6 7 8. For B union D, there are common numbers are 7 and 8 between B union D, right? B union D, there is there common number? No. So just write the numbers in order. Okay, that is 3 4 5 6 and 7 8 9 and 10. Now A union B union C. So for the union of three numbers, three sets, first of all we have to write the common number between A, B and C. 3 in 3, the common numbers in 3. So the common numbers in 3 are, is there any common number between 3? No. So first of all you have to find if there is any common number in A, B and C. Okay, all together. If there is no common number, then find common number between A and B. Is there any common number between A and B? Yes, there are common number between A and B, that is 3 and 4. Then find common number between B and C. So there are common number between B and C are 5 and 6. Then find if there are any common number between A and C. Is there any common number between A and C? No. After that, write all the other numbers, that is here 1 and 2 for A, B is already written, okay, and the other number in C are 7 8. Now just write in order, that is 1 2 3 4 5 6 7 and 8. Okay. Now A union B union D. A union B union D. So first of all we have to find any common number between these two, between these three sets. Okay, is there any common number? A, B and D. A, B and D. No, there is no common elements which belongs to A, B and D. A, B and D. So just find common elements between A and B. So the common elements between A and B are 3 and 4. Between B and D are, there is no common element between B and D, and also there is no common element between A and D. So just write the other element, that is 1 and 2 for A, for B 5 and 6, and for D 7 8 9 10. Okay. Now the last one, B union C union D. Is there any common element in B C D? B C D. B C D. No. Now we find common element between B and C, and there is common element between B and C 5 and 6. Now common element between C and D 7 and 8. And between B and D there is no common element between B and D. So just write other element, that is 3 4 for B, there is no other element in C remaining, and D 9 and 10. So this is the answer. Okay. Now question number 5. Find the intersection of each pair. So you have to find the intersection. Okay. So X intersection Y. What is intersection? The common element between X and Y. So the common element between X and Y is 1 and 3. So X intersection Y equals to 1 to 3. Similarly, A intersection B equals to only A, because only A is common in A and B. Okay. Now this set equals to, as you know, 3 6 9 comma some dots, and for this 1 2 3 4 5. Okay. So A intersection B equals to the only common element between these two sets is 3. So A intersection B equals to 3. Now for this question, A equals to 2, 3, 4, 5, 6. For this question, B equals to 7, 8, 9. But there is no common element between these two sets. So A intersection B equals to 5, and so A and B are mutually disjoint sets. Okay. Now the last is A equals to 1 to 3, B equals to 5, but there is no common element between A and B because B contains no elements, so there is no common elements between A and B. So A intersection B equals to 5. So it is also mutually disjoint sets. Okay. Now 6, there are some sets A, B, C, D. You have to find A intersection B. So what is A intersection B? Is there any common element between A and B? Yes, there is common element 7 and 11 between A and B. Now between B and C, is there any common element? Yes, there is common element 11 and 13. Now A intersection C intersection D. A intersection C intersection D. Okay. So first of all, we have to calculate A intersection C, then D, or you just find if there is any common element which belongs to A, B, A, C and D, these three sets. Any elements which common to these three sets. Is there any element which common to these three sets? A contains 3, 5, 7, 9, 11. C contains 11, 13. So common elements between A and C is 11 and D and C is 15. But there is no common elements which belongs to A, C and D also. So this will be 5. Now A intersection C. A intersection C, yes, there is 11 common in A and C. B intersection D. B intersection D, there is no common element between B and D. So this will be 5. Now A intersection B union C. So just write A 3, 5, 7, 9 and 11 intersection B union C. So what is B union C? So first of all, we have to write the common elements between B and C, that is 11 and 13. Then the other element, that is 7, 9 and 15. Now we have to calculate the intersection between these two sets. There are common element between these two sets 11, 9 and 7. So this equals to 11, 9 and 7. You can write 7, 9, 11 also. Now A intersection D. Is there any elements between A and D? Common between A and D? A and D, no. So this will be 5. Now this will be A intersection B union D. You do it as homework. Okay. Now question number 9. So first of all, we have to calculate A intersection B. Is there any element between A intersection B? Common element between A intersection B? Yes, 7, 9, 11. 7, 9, 11. Okay. So 7, 9, 11. Intersection B union C. Okay, B union C. B union C. We already calculate B union C here. Okay, so this is B union C. So just write 11, 13, 7, 9, 15. Now the common element between these two sets are 7, 9 and 11. Okay, 7, 9 and 11. So this is equals to 7, 9 and 11. And the last one is your homework. Do it as homework. Okay. Now question number 7. So a equals to x such that x is a natural number. So since x is a natural number, so the set will be 1, 2, 3, 4, 5, 6, comma dot. Okay, b x is an even natural number. Even natural number means 2, 4, 6, comma dot. X is odd natural number. Okay, so c is odd natural number. So c will be 1, 3, 5, 7, and d will be x is a prime number. X is a prime number. So for d will be 2, 3, 5, 7, 11, such that. Now a intersection b. So the common elements between a and b are 2, 4, 6, and the next one will be 8, and the next one will be 12. So a intersection b equals to 2, 4, 6, comma dot, and this set represents set b. A intersection c, there are common elements between a and c, that is 1, 3, 5, 7. These are the common elements, 1, 3, 5, 7, and so on. And 1, 3, 5, 7 and so on represent option C, that is set C. Now a intersection D. Is there any common element between a intersection D? Yes. The common element is 2, then 3, then 5, then 7, then 11, and so on. And it also represents set D. Now B intersection C. Is there any common element between B and C? No, because B is set of even natural number and C is odd natural number. So there is no common element. So this equal to 5. Now B and D. Yes, 2 is the even prime number. So the only common element between B and D is 2. Between C and D, there are common element between C and D are 3, 5, 7, 11, and so on. Three, 5, 7, 11, and so on. Okay. Now question number 8. Which of the following pairs of set are disjoint? Okay. Which of the following pairs of sets are disjoint? That is mutually disjoint. When two sets are called disjoints if there is no common element between them. So this is the first set. Now the second set will be 4, 5, 6. Okay. 4, 5, 6. Now between these two sets there are common elements. There are common elements, and the common elements is 4. Okay. So for these two set, intersection will be 4 and this is not equals to 5, that is 4 not equals to 5. 5 means there is no element, but here is the element 4. Okay, so this is not disjoint, this is not, that is these are not disjoints, these are not disjoint. Okay, now between these two sets, intersections e a e I o u and there is e, so a e I o u intersection c d e f equals to e not equals to 5, so these are not disjoint, so this will be here. Okay, now x suggests x is an even integer, x is an even integer, even integer, even integer. Okay, so this will be some dots, then -4, -2, -4, -2, and this will be 0, 2, 4 and so on. And for an odd integer, there will be CS this. Okay, so okay, 2, 4, 0, this is an odd integer, we get -5, -3, okay, -1, 1, 3, 5 and so on. So there is no common element between these two sets, so they are disjoint. Now question number 9. Question number 9 says that ABC and you have to find all these numbers. Now question number 1, A minus B. So you have to find the common elements between A and B first. So the common element between A and B are 12, and there is no other common element between A and B. So just write all the numbers, all the remaining numbers in A. So 3, 6, 9, 15, 18 and 21. This will be A minus B because A minus B contain only elements of A which is not in B. Okay. Now we do the question number 8. Okay, that is B minus D. So first of all we have to find the common element between B and D. 20. Anything else? No. So just write the remaining elements in B, that is 4, 8, 12, 16. Okay, and the remaining question are your homework. Do it as homework. If you feel any problem, then you must comment below. Okay, then you must comment below and I will do the answer. Okay, so that's all. No, there is another question number 10 also. Sorry, question number 10, 12, 11, 12 are also here. Okay, so x equals to ABCD and y equals to FBG DG. Find x and x minus y. So first of all you have to find the common, that is B and B between x and y. Is there any common? Yes, D. So x minus y equals to A comma C. y minus x. So you have to write the remaining elements in y because y is in the first place, that is f comma g, and the intersection of x and y, the common elements, that is b and d. Very easy. Okay. Now 11, if R is the set of real number and Q is the set of rational number, then what is R minus Q? So real number, the set of real number are the addition of rational number and the addition of irrational number. Okay, that is the set of T. So R minus Q equals to T, that is a set of irrational number. Okay, this is the answer. Question number 12, you have to find the disjoint sets. Is true or false? Okay, so the intersection of these two set is 3. So this is not equal to 5, so this is not disjoint, so this is false. The intersection between these two sets are A not equals to 5, so this is not disjoint, so this is also false. Intersection between these two sets 2, 6, 10, 14, yes, there is no common elements, so intersection equals to 5, so this is disjoint, so this is true. And for the last question, intersection equals to 5 because there is no common element, so this is disjoint, so it is true. Okay, so that's all. If you like this video, then please like, share and subscribe. Okay, and please support me by subscribing and sharing. Okay, that's all. Goodbye, tata.